Hi, welcome back to a new video on Algebra 1. Today we'll be starting off with the basics. So, for most of us, mathematics begins with numbers. We have special names for different types of numbers. The integers are whole numbers that we use for counting, and their opposites too. Numbers are greater than 0 are positive numbers, and numbers less than 0 are called negative numbers. The number 0 is neither negative nor positive. When we divide one integer by another non-zero integer, we form a rational number. All integers are rational numbers, but not all rational numbers are integers. For example, 1 by 2 is not an integer, but a rational number. Not all numbers are rational. Numbers cannot be written as one integer divided by another are called irrational numbers. For the example, square root of 2 is irrational. In the following chapters in this video, we're going to encounter new types of numbers that arise and take square roots. When we take the square root of a negative number. That's right, a square root is of a negative number. It's not legal after all, although such square roots are called imaginary numbers. However, you will need to wait until the following chapters to learn more. But it took mathematicians thousands of years just to get from integers all the way to imaginary numbers. It will just take you a few more chapters. But note that you cannot take the square root of a negative number. One rule is that mathematicians accepted a long time ago, only to discover that it didn't need to be a rule after all. But now we'll stick with the real numbers, which is basically the numbers we can write as decimal, even if we have to use infinitely many decimal places. For example, integers and rational numbers and irrational numbers are real numbers. By using arithmetic to combine to form other numbers, our usual tools are addition, subtraction, and multiplication, and division, and exponents. We also call these the tools of operation, which I'll give an example of each. So here's one, addition. 2 plus 4 equals 6. We'll describe as whatever order of operation we do. Addition will be used as the key, as the adding sign, of course. Then 2 minus 4 makes minus 2. And whenever doing subtraction, and if we're trying to tell us what tool we're using, we're going to use this as the subtraction symbol. Like showing that this subtraction. And 2 times 4 equals 8. And you get the idea. We're going to do multiplication to prove that, show that this is multiplication. Then 2 over 4 equals 0.5. So for this, we're just going to do simple division sign. And 2 to the power of 4, which is equal to 16. We'll just say this as x to the power of y. So, now, this one operation to be careful with is division. Here's one of our simple rules. You just cannot divide by 0. While each operation in itself is simple, we need some ground rules when we start using these operations in combination. For example, what do we mean when we write... Well, give me a second. What in the world? Okay. Oh, that works. I just want it to be deleted. Yeah, that works. Okay. So, and what do we mean by when we write 2 plus 3 times 4? So do we mean by add 2, then multiply by 4? If so, we get 20 because 5 times 4 makes 20. So, or what do we mean if we multiply 3 and 4, then add 2? We'll get the answer as 14. So, we need to choose one rule and stick to it. It's clear what mathematical expressions with many operations mean. The rule for evaluating mathematical expressions is the multiple operation actions called the order of operation. Here, they are Number 1. If the parentheses are in the expression, evaluate all expressions within the parentheses working from the inside out. Compute each expression inside of the parentheses using the order of operation. Perform all exponents. Perform all multiplication and divisions from left to right, and perform all addition and subtraction from left to right. So, here are a couple of examples we could use to help you better understand. So here, we'll do 5 plus 3 times 6 to the power of 2. So, the first step we'll do is 5 plus 3 times 36, because we're doing exponential first. This will show that what we're doing first. Then 5 plus 3 times 36 will get us 108. Means that we're doing multiplication during that time. Then 5 plus 108 makes 113, which means we're doing addition during this time. So as you could see, we started with exponents, then we went on with multiplication, then we ended at addition. So, if we want to add before multiplying, we have to put 5 plus 3 in the parentheses. So, I'll show you how that'll look like. Here you go. So, we'll start with the parentheses first. Means that 8 times 6 to the power of 2. Then we'll do exponents. 8 times 36. Then we'll do multiplication, which gets us 288. As you can see, 288 is not equal to 113. So there's a big difference of adding just these two signs into an expression. Okay. So, now it's your turn to solve some problems. So, evaluate the following expressions which I'll eventually give you, and pause the video to take some time to solve them. Here's number 1. 6 plus 3 times 8. So, I'll just pause the video to give some time to solve the question. Okay, hopefully you solved the question and kept it on a notepad, so you could check your work after that. So the first thing we do is multiplication before addition. Means that it will be equal to 6 plus 3 times 8, means that will be equal to 6 plus 24 makes 30. Here you go. Our first answer, number 1, is 30. Moving on to number 2. So, number 2 is 6 plus 3, but the parentheses times 8. It's the same problem, but adding parentheses in it. So, pause the video, give some time to solve this problem too. Okay, hopefully you're done and you got the correct answer. Let's start. So we'll do the parentheses before multiplication. So, we'll do 9 times 8, because 6 plus 3 makes 9. 9 times 8 makes 72. The answer, number 2, is 72. The next one, number 3. Number 3 is 17 minus 2 times 3 to the power of 2. So, I want you to pause the video and take some time to solve this problem. I hopefully hope you get the right answer and you're done with the problem. So let's get straight into it. So 17 minus 2 times 3 to the power of 2. So to do that question, I don't know why we write it, but okay. To do that question, you'll start off with 17 minus 2 times 9. We'll do the exponent, then the multiplication, then the subtraction. So we'll do the next step, 17 minus 18. Oh my god, what? I don't know why we're 118. Yeah, 17 minus 18. So, we did the multiplication here, and we did the exponents in here. nths over here. Now we're doing the subtraction. So 17 minus 18 equals -1. That's the answer for number 3. Now for the next question I want you to solve, number 4. So number 4 is going to be 17 minus 2 times 3 to the power of 2. And be careful, there's some parentheses here. Okay? Pause the video and do the problem. Hopefully you'll get it correct. Okay, so we'll start solving the problem. Remember, parentheses, then exponent, then subtraction. Let's follow that. So 17 minus 6 to the power of 2, because 2 times 3 gets you 6. 6 to the power of 2, because the power of 2 is outside the parentheses, it'll get stuck onto this one. So, after doing that, we will get 17 minus 36, which is equal to -19. So, we did subtraction here, we did exponential here, and over here we solve for the parentheses. Okay, good job if you got this correct. So, next up is number 5. So for number 5, we're going to do 17 minus 2 times 3. And this time, the entire expression to the power of 2, entire expression is under parentheses. So think about what you have to do. Okay, we'll start solving now. So, we'll be first doing the parentheses, multiplication before subtraction inside the parentheses, then exponent. So, we'll do 17 minus 6. Okay? And then remember, you have to always add the parentheses and the square of it. So 17 minus 6 will get us 11 to the power of 2, which gets you 121. Here's a cool trick. So whenever you're multiplying anything by 11, okay, let's just say 11 times 13. You take the first number and put the next number over here, leave a gap in the middle, and you have to just add these two numbers. 1 plus 3 makes 4, so you'll get 143. So for any number you're multiplying by 11, put the first digit here, put the next digit on the other side, leave a tiny gap there, add 1 plus 3 gets you 4. You'll get the answer to 11 times 3. So that's what we did with 11 times 11, which gets you 121. Yeah. Why is it going crazy? Don't go crazy. Okay, good. So that's the answer to the 5th question. So for number 6, it's going to be a tough one. If you solve it, you'll get a big smiley face. So, if you solve this question, 15 minus 3 divided by 2 times 3 minus 2 to the power of 2 times 3 divided by 6, you'll get one big smiley face. So, let's start. Okay. We'll work out. I'll explain you the entire process. So, we're first doing the parentheses, working inside and out, and following the appropriate order of inside, then the multiplication, and then division, then subtraction. Let's get into it. So, first up, we're going to be doing this. So that means 12. This is really, okay, so, why is this thing thin? Okay, who cares? 12 divided by 2 times 3 minus 4 times 3 divided by 6. Now, doesn't this look more easier to solve? Oh, I know why. Anyway, 12 divided by 2 makes 6 times 3 minus 4 times 3 divided by 6, which gets you 12. Oh my god. 12 divided by 6 means that 18 minus 12 divided by 6 is what? 2 means 16. And if you got 16, here's one big smiley face. And a little confetti. Good. Maybe a little hair too. Okay. No, I cannot draw hair for absolutely no reason. Bro, get the eraser. Yeah. Let me try drawing the hair now. A little curly. Don't know why I added that. Oh, God. Drawing hair so easy. I mean, hard. What? Yeah, that's better. Just like that. Enjoy your smiley face with the confetti. If you solve the problem correct. Next on, we will do some exercises which will be your homework. I mean, if you want to do it, if you want to do it, you could do it. But if you didn't want to do it and too lazy, that's your fault. You're missing out on that learning. So here's going to be your homework for today. 3 to the power of 2 plus 4 times 2. That's going to be problem number 1. And you'll get all the answers at the end of the video, okay? Times 2. That's going to be the first one. Next one is 5 minus 8, parentheses, times 2 plus 7. Next one is going to be 3 to the power of 3 minus 5 to the power of 2. Give me that. Yeah, minus times 5 minus 8. Next one is going to be 8 divided by 6, which is under parentheses rule, minus 2. 1 second. Minus 2 plus 5. The next one will be 8 squared divided by 4 squared plus 3 times 4. Next one is going to be 11 times 6, 2 to the power of 2 minus 3, 6, yeah. That's going to be all your homework problems. At the end of the video, you'll get the answers and hopefully you got it correct. So, we'll move on to the practice problem we're going to be doing. So, the first problem is going to be Josie has 14 marbles. 14 marbles, and Beth has 8 marbles. Josie counts. My God, that's a lot of L's. Josie counts all the marbles by starting with her marble, then adding Josie. How can I not spell Josie? Josie marbles. If they add correctly, will Josie and Beth find the same number of marbles? Okay. So just think about it and pause the video and think about the question and try to solve it by yourself. Okay, hope you had enough in time and as you thought about the question, try to solve it. So let's get straight on it. So Josie starts with 14 and adds 8. So she already has count total of 14 plus 8, which gets us 22 marbles. Then Beth starts with 8 and adds 14, which gets the same amount of marbles. So they find the same amount of marbles. This shouldn't be a surprise, no matter how we count the marbles. There's always the same number of marbles. Problem 1.2 example is the obvious, yet important of the commutative property of addition. This is a fancy way of saying the sum of two numbers is the same no matter what we add in whichever order we add them in. Okay? So this is just the very big example of the commutative property. Commutative adding. Property of addition. Oh my god. Property of addition. So, we'll move on to problem 1.3. So, in problem 1.3, Joe and Rini. Oh no, I was cutting midway. Rini. Why is it erasing midway? What? Something wrong? I think it's wrong. Anyway. Rini are counting. My hand is so good, I know, right, guys? Tiles on their deck. Their deck. Oh my god, my hand looks so beautiful. Their deck shown, below. So, here's the deck. It's going to be 1, 2, 3, 4, 5, 6. What good, beautiful drawing, guys. With a 1, 2. Oh my god, the drawing is beautiful. 3. Yeah, see? 1, 2, 3. If I did that right. 1, 2, 3, 4. Yeah, I did that right. Okay. Oh, what the? Okay. Yeah. I don't know what happened there, but okay. Yeah. So Joe sees that. Oh my god. Joe's say that there are 6 columns. Can't write. Can't spell. Columns of 4 tiles. 4 tiles each. So, if there's 6 by 4 tiles, Rennie says there are 4 rows with 6 tiles 6 tiles each, which is 4 times 6. Who is correct? So, it's just a simple problem again. Okay. So, in 1.3, they're both right. Because if we count the columns, we have 6 columns of 4 tiles each. Or, oh, it's going to be long. 4 plus 4 plus 4 plus 4 plus 4 plus 4. Is that how many? 1, 2, 3, 4, 5, 6. That's correct, right? Yeah. Which is also equal to 6 times 4 is 24. And if we count by rows, we'd be having 6 plus 6 plus 6 plus 6, which is then equal to 4 times 6 equals to 24. We're counting the same group of tiles in both cases, so we must get the same number. Can't speak. Also, as you might have guessed, we call the fact that the commutative property of multiplication. This is just a very big way of just saying the commutative property. Oh my god, I can't spell. Property of multiplication. So, more examples of the commutative property of multiplication are 5 times 3 equals 3 times 5, negative 7 times 8 equals 8 times negative 7, and 3.5 times 1 over 8 equals 1 over 8 times 3.5. So, as with addition, we can use variables to write an equation showing that the commutative property of multiplication. So, we could be saying A times B is also equal to B times 8. So, the order doesn't matter for addition nor multiplication. What about subtraction division? So, in problem 1.4, state whether each of the equations below is true or false. Let me write that. State, oh my god, whether, oh my god, I can't spell or write or speak. Whether each of the equations below is true or false. So, we'll start out with A. 2 minus 5 equals 5 minus 2. B. 2 plus minus 5 is equal to minus 5 plus 2. My handwriting is absolutely magnificent. Okay, next one is going to be 8 over 4 equals 4 over 8. Then D is going to be 8 times 1 over 4, which is then equal to 1 over 4 times 8. So, pause the video, take some time to, about this question, state whether each of these equations are true or false. Okay, hopefully you had enough time to state whether each of these equations are true or false. Okay, so let's get started. Because 2 minus 5 is equal to minus 3, and 5 minus 2 is equal to 3, the given equation is not true. We can use the symbol this to show it's not true. False. So number 1 was false. So we can see that order does not matter for subtraction. This makes sense because the first number in subtraction is treated differently than the second. The first number in amount is the amount of being taken away, while the second is the amount being being taken away. We therefore say that subtraction is not commutative because the reversing order usually changes the result of subtraction. So for the next one, we have 2 plus minus 5 equals minus 3, and minus 5 plus 2 equals minus 3. So this is a true statement. This shows that we can think of subtraction as addition of a negative number. We can use the commutative property of addition to reverse the numbers that are being added, because 8 divided being added. So for the next one, 8 divided by 4 equals 2, and 4 divided by 8 equals 1 over 2. The given equation is not true. Just with subtraction, order matters with division. Again, this is not a surprise, as splitting 8 into 4 equal pieces is very different than splitting 4 equals 8 different pieces. Now for the last but not least problem, both sides of the equation is equal to 2. Just as we can turn subtraction into an addition of a negative number, we can turn division into multiplication. We could use the commutative property of multiplication. For example, 8 divided by 4 as 8 times 1 over 4. We have 8 times 1 over 4 equals 1 over 4 times 8. So this is true. Okay, now for the next problem, 1.5. Okay, this is going to be our last problem. Maybe this is going to be the last problem of the day. Never mind, this is not going to be the last problem of the day. Okay, so in American football, a touchdown is worth 7 points. A field goal, oh my god, I can't spell. Field goal is worth 3 points. Oh my god, I can't even write. $3 points. Oh my god, I'm just gonna be erasing this. Points. And a safety is worth 2 points. In the first quarter, between the Eagles and the Cowboys, the Eagles score a field goal. Score a field goal. Oh my god, right. This is getting really annoying. Goal. So, Dan scores a touchdown. while the Cowboys only score a field goal. In the second quarter of the game, the Cowboys I'm just going for second quarter to make it a little faster. I'm going to write 2/1/4. And this means second quarter, okay? In the second quarter of the game, the Cowboys scored a touchdown. Can't even spell touch anymore. Touchdown. While and the safety, while the Eagles only score a safety. So how many points did each team score in the first quarter? Each team in first quarter, that means quarter, why am I writing this? Oh my god, the eraser. Team in first quarter points, and each team in second quarter points, and who is winning after second quarter points. This is horrible handwriting, but it's okay, guys. Okay, so in the first quarter, the Eagles scored the 3 plus 7, which is 10, and the Cowboys only scored 3 points. In the second quarter, Eagles scored 2 points, while the Cowboys scored 7 plus 2 makes 9. So who's winning at the end? 10 plus 2 makes 12, and the Cowboys have scored 3 plus 9 makes 12. So they're both tied. Yippee! And write down in the comment, who do you like more, the Eagles or the Cowboys? I personally like the Eagles more. Just write down in the comments which one you like more. So, we can grouping the points scored by each team in the quarter. We have Eagles first quarter plus Eagles second quarter equals the Cowboys first quarter plus the Cowboys second quarter. Or we could just write 3 plus 7 plus 2 equals 3 plus 7 plus 2. This is just a humongous thing of saying the associative property of addition. Now that's a big way of just saying associative property of addition. So, now, that's done with problem 1.5. We'll move on to 1.6. So, for 1.6, it's a humongous problem, and I'm too lazy to write it, so I'm just going to say it to you. My God. So, Bart and Lisa are using a pile of blocks to build the box, shown at the right. I can just draw the box if you want. Let me just draw this box. I'm really bad at drawing 3D shapes. It's not my fault. I took art class. The new art class. Art sucks. Actually, I hate this. I just not even an eraser. Go away faster. Screw it, I'm not drawing. Okay. Shown at the right. They like to figure out how many blocks they use. The box is solid, so each layer has the same number of blocks as the top layer. Lisa sees that there are 3 times 4 equals 12 blocks on the top layer, and there are 5 layers. So she says about 12 times 5 equals blocks total. But Bart disagrees. he says 4 times 5 equals 20 in the front face, and the other two layers, just like the face in the middle, are in the back. So 3 layers of 20 blocks each means 3 times 20 equals what? Who's correct? So Lisa counts 12 times 5 makes 60 blocks. So 12 times 5 makes 60 blocks. And Bart counts 3 times 20 makes 60 blocks. So it's the same thing again. They're both correct. It's just another gigantic way of saying the associative property of multiplication. So Lisa counts the blocks computing 3 times 4 times 5. But Bart counts them by computing 3 times 4 times 5. The associative property tells us that 3 times 4 times 5 equals to 3 times 4 times 5. It's just different because they added parentheses. So let me show you. Let me explain. What I meant like this. See, the parentheses popped in. It's the same thing as writing 3 times 4 times 5. And this counts as multiplication. So that means A times B times C is equal to A times B times C. And this is the last problem for our class look, and my handwriting has degraded immensely. Holy crap. Oh my god, I can't even write. And that's the wrong pen. Actually, I like that pen better, but I started out with the darker shade. Sadness. Yeah, that's better. This is the associative property of multiplication. Okay. So this is the last problem of our classwork. And sadly enough for you, I have to give you more homework. So, here you go. I'll give you homework to make this quick. So, which of the following equals 63 minus 27? A, 27 minus 63. B, minus 27 minus 63. Oh my god, I can't still write. C, 27 plus 63, and D, minus 27 plus 63. Okay, I'm only giving you this problem and one more problem, so, yeah. You better be happy. I would have given you 4 more problems, but you better be happy I'm only giving you 2. So we just have to do compute the following. Oh, I can't even spell following now. Oh my god. So, 63 times 2 over 7 times 2 over 63. Now, this combined with the other problems, yeah, we have to solve this. So since we're reaching near the end of the video, I'll help you. I'll give the answers to the problems, you know, the first problems. So, yeah, I'll help you. I'll just give you the answers for the first problems, because hopefully you solved it, and, yeah. But if you didn't solve it yet, I'll give you some time. Just pause the video and solve the questions. Yeah, so we'll continue and do the homework problems. How fun. You and I hate it, but I have to do it. So, That's a one big smiley face. That's a way to... Oh yeah, here's the homework. Okay, so... Why is it just... That's better, okay. So I'm not willing. Can you stop? Can you... Okay, I'll just... Cut. Okay, never mind, undo that. I don't like cutting it. So... Bro, I'm getting rage baited. Oh, screw that. I just want, duplicate. Delete. I want this entire screen done. No, I want this entire... That's the eraser. Thank God. This entire screen duplicated. Duplicate. Good. Let's go. Push, go down. Go down. No. No, I'm getting mad. I'm getting really mad. So, you know what? Screw this. Wait, I can copy. Shoot. So smart of me. Copy. Go all the way down. Wow, it's way too down. How do I paste it? Don't even know how to use this dumb computer. I mean, iPad, whatever. Yeah, it doesn't work like that. Okay, screw that. This one. I'm getting mad. I'm getting really mad. Okay, screw that. We'll just do it. Yeah. Okay, so for the first problem, 3 to the power of 3. I mean 2. Oh my god, I'm already losing memory loss. Plus 4 times 2 makes 9 plus 4 times 2 makes 9 plus 8 equals to 17. So it's going to be exponent, the multiplication, and addition. Then for the next one, 5 minus 8 times 2 plus 7. Don't forget the parentheses, they're very important. Means that we evaluate the expression within the parentheses first, means minus 3 times 9, which gets us minus 27. Next one is 3 to the power of 3 minus 5 squared. Oh my god, I can't. I'm giving up. My hand is about to break. Parentheses times 5 minus 8. We'll do the order of operations within the parentheses. Means that 27 minus 25 times 5. The parentheses you can never forget. Minus 8. Makes 2 times 5 minus 8 means 10 minus 8 means 2. Next one, 8 divided by 6 minus 2 plus 5 will be 8 divided by 4 plus 5 equals 2 plus 5, which is equals 7. So we'll first do the parentheses, then division, and addition. Okay, next one will be 8 squared divided by 4 squared plus 3 times 4, which is then equals 64 divided by 16 plus 3 times 4, which is equal to 4 plus 12, then which is equal to 16. Yeah, so we first did the exponent, division, multiplication, then addition. Next one. It's a pretty hard one, but I think you guys can do it. 11 times 6, 2 to the power of 3, minus 3. Okay, so this one will be 11 times 6 to the power of 1, because 2 minus 3 minus, oh no, wait, this is 2 to the power of 2. What am I thinking? This was 2 to the power of 2. So, I mean, 4 minus 2 if you do, I'll do it right here. 4 minus 3, because you only do, because you do that, power this. 4 minus 3. My hand is absolutely magnificent. 4 minus 3 will get you 1, means 11 times 6 over 1, which gets you 11 times 6 makes 66. The next one, first we just, let me explain. The first one we did expression and exponent, then we performed the exponent, then we did the multiplication. So this is for the 1.3 now, exercises. So for that, we first did 63 minus 27. We wrote it as 63 plus or minus, plus minus 27, which we can do the commutative property of addition to do 27 minus 27 plus 63, or which is also equal to minus 27 plus 63. This had the parentheses. So this answer was pretty valid, or if there was an answer like this, that was pretty valid. Let me just check real quick. Yeah. This answer was the correct answer, D. So the next problem, the one I gave you, was 63 times 2 over 7. That's a good 7. Times 2 over 63. So we first did the commutative associative property multiplication. We ordered the terms in a way that made the computation easier. Means 63 times 2 over 63 times 2 over 7 equals 2 times 2 over 7 equals 4 over 7. That's the final answer for the homework. I hope you had a great time listening to this video. I hope to see you in the next video. He has a big smiley face. Hopefully watching all the way to the end of the video. Thank you for listening, and bye.